You've probably seen this cool looking effect of pendulums waving from left to right. However, something very special happens when we transform these into a double pendulum. Because then, as you can see, the pendulums go completely crazy. And this is what mathematicians call a chaotic movement. And one of the key characteristics of a chaotic movement is that a very small change in beginning position can lead to a completely different outcome. And I found them so fascinating that I really just had to figure out how to do these in Blender and then to show you how these are done. So inside of geometry nodes, let's get started by clicking on the cube and creating a new geometry nodes for it. However, since we do not need the actual cube for this, we're going to remove the group input and we're going to press Shift A and we're going to start off with a curve line node. And at the moment, this curve line consists only of 2 points. However, this line is going to become our double pendulum, so it should not have 2 points, no, it should have like a third point in the middle, so that it can actually bend, right? So to do this, we want to resample our curve with a resample curve node. And the count is now on 10, but now we have like 10 points, but set this on 3 so that we only have 3 points. But before we're going to do anything of the simulation itself, we're going to implement the parameters into geometry nodes. Let's first have a look what these parameters are. So these are all the parameters that we're going to implement for our pendulum. And each of these parameters we're going to implement with a store named attribute node. So let's start with the first 2 parameters. So let's first add in a store named attribute node. And this first attribute is going to be M1. We see we have M1 and M2. M1 is the mass of the first pendulum and M2 is then obviously the mass of the second pendulum. So this first store named attribute, let's name that mass 1. And then we can duplicate this with Shift D and we can name this one mass 2. And for now, we're going to set both of them on a value of 1. Later, we can change these, of course. Now let's implement L1 and L2. And this is basically the length of each pendulum, of course. So let's take this store named attribute node, Shift D it to over here and name this length 1. And then duplicate it again and make this length 2. And let's keep this on a value of 1 as well. The next 2 parameters are going to be Theta 1 and Theta 2. And these are basically the angle of the first and the second pendulum at a certain frame. So let's take the store named attribute again, Shift D it over here, and let's name this Theta 1. And then let's take it again and do Theta 2. Now the last 2 parameters you see are omega 1 and omega 2. And these parameters are basically going to tell us when we update the pendulum from one frame to the other, how much should this angle change? So how big is the angular velocity between 2 frames? Basically, you could say this value determines how fast the pendulum goes. So let's implement those 2 by taking the store named attribute again and name this omega 1. And then let's duplicate this into omega 2. But these, let's make that a value of 0 and a value of 0 so that the pendulum will have a beginning velocity of 0. So now that we have all the parameters, we can actually start simulating already. So let's do Shift A and do a simulation zone. Place that over here and connect the store named attribute like that and the simulation node like this. The first thing that we're going to simulate is that Theta 1 value. So we're going to update the angle over time. So to update the value of this store named attribute, we're going to take it and press Shift D to duplicate it right over there. And as we can see, the new Theta 1 value should be the old Theta 1 value plus the omega 1 value. So to get this Theta 1 value, we can do a named attribute and then set this on Theta 1. And then we can connect that like this. But now it's basically calling itself. Now we're basically saying, okay, the new Theta 1 should be the same as the old Theta 1. But we want to say plus omega 1. So let's do a math node, which we keep on add. And we want to add omega 1 to this. So let's Shift D this named attribute and let's make this omega 1, and let's connect that with the add. And that's basically it for the theta 1 over here. Now we need to do the same thing for theta 2. So let's take this store named attribute and let's press Shift D to duplicate it over here. And now we can basically take these three nodes, Shift D them to over there, change these to theta 2 and omega 2, of course, and then connect it with theta 2 like this. And now we're basically already updating the angle in a good way. However, of course, we also need to update omega 1 and omega 2 over time. Otherwise, this value is never going to change because this is always 0, of course. And to update omega 1 and omega 2 over time, we're going to make use of one hell of a formula, as you can see. When I saw these two formulas, I was like, okay, I have two options. I can either spend half an hour explaining this entire formula in very much detail, but that would be quite useless because you really don't need to know all the ins and outs of this formula. So what I decided to do instead is pre-create these formulas in a different Blender file. So in the link in the description, you can find a Blender file with these two node groups in them. And then when you have downloaded that Blender file, you can go into File and then into Append. You can search for that Blender file and then click on it. And then over here in the node tree, you can click on omega 1 equation and omega 2 equation and then append it. And then if you go back into geometry nodes, you will see if you press Shift A and you go in the group, you have omega 1 and omega 2 equation, which is perfect. But for now, let's first do omega 1. So to update omega 1 over time, we want to take the omega 1 value, Shift D it to right over there, and then we basically want to do the same thing as we do over here. So we first want to take the original omega 1, connect that over here, and we want to add something to that. The thing we want to add to this is the outcome of the omega 1 equation. So connect that like this. But what we need to do is we have to connect like all the named attributes of these parameters with these sockets. So let's start doing that with the named attribute for mass 1, like this, for example. And let's also do mass 2, kind of like that. Now, if you want, you can click over here to like hide the node or like make it smaller. And then let's skip gravity for now. But then you can also take this named attribute, for example, and make it length 1 and connect the length like that. And then also do length 2, connect it like this. It's all the same story, of course. Let's do the same thing for theta 1 and theta 2. So theta 1 like this and theta 2 like that, just by pressing Shift D to duplicate all these things. Also for omega 1 and omega 2. So let's take this one, omega 1, and connect it over here. And let's do omega 2 and let's connect it like this. This way we're making sure that everything still works procedural and all the controls that we're going to have later with the pendulum are going to happen only in these store named attributes, and we don't have to change anything in the simulation, for example. For omega 2, we practically do the same thing. So let's take this store named attribute, Shift D it over here, make it omega 2. Let's do this named attribute again, connect it over here, make it omega 2. And we want to add something to this, and you guess it, we want to add the omega 2 equation. So let's do Shift A and go into group and do omega 2 equation. And then let's connect that like this. For the omega 2 equation, we want to do the same thing. We have the same parameters, as you can see. So we can just take all of these nodes, Shift D them to over here, and then we can connect them in order like that. Make sure that you're skipping the gravity, of course. So then like this and like this and like this and like this. Now for the gravity, we want that to be the same number for both the omega 1 equation and the omega 2 equation. So what I thought would be good is if we make some space over here and we add in our value node and we make the gravity like minus 0.01 so that the pendulum will go downwards, and we connect it like this, and then we can also connect this one with this gravity. So that's always the same thing. But now we're only updating the angle of the pendulum, but we're not really changing like anything in the position or something like that. We're not changing anything at all in this pendulum at the moment because we don't have a set position node or something like that. So let's actually do a set position node. And with the set position, we're going to determine the X position and the Y position of the second point over time. And before we do that, I recommend that we press numpad 7 to go into top view so that we can see the Y-axis and the X-axis like this, because that's like the space that we are going to work in. Later, we can of course manually rotate the pendulum so that it actually falls down. But for the formulas, it was easier to use X and Y. So what we want to change is the position over here. And as you can see, we want to have control over the separate X and Y axis. So let's do a combine XYZ node, connect it with the position, and now we have the separate X and Y. You see the X axis is the sine of theta 1. Let's first create that. So let's do a named attribute node, which we set on theta 1. And from this, we want to get the sine. So let's do a math node, which we set on sine and then connect it like this. And then we have the sine already. Now we could, of course, connect this one with the X. However, we also have to do this times the length of this first part of the pendulum. And to do this, we do another math node, which we set on multiply. And let's take this named attribute, shift D it to over here, make this length of 1, and then connect it like this. This will make sure that the pendulum actually stays as long as it needs to be, and it's not like going into everywhere. So now that we have the x-axis of this, let's also do the y-axis. So for the y-axis, we want to have the cosine of theta 1. So let's take this sine node and let's shift D it over here, and let's change this into the cosine. And then of course connect theta 1 like this. For this we want to do the same thing. We want to multiply it with L1 again. So let's take this multiply node, shift D it over here. Let's connect the cosine like this and the length like that. And then this is going to be our y-axis. So now we have the x and y axis for the first pendulum. However, if we press play, you see our curve disappears. And the reason for this is because this set position node is now doing it for the entire curve and not just for this middle part. So we want to tell Blender that so that it should only do it on this part. And to do this, we're going to import an index node. And the index of the points goes like this. So over here is index 0, here's index 1, here's index 2. So we want to say only do it for index 1. Let's do a compare node, which we set on integer. And we want to set this on equal so that we can say everywhere where the index is equal to 1, it should do this set position node. And now if we press play, you will see we already get kinda a pendulum movement, kind of. However, this is not really like a pendulum yet because this second pendulum is not doing anything yet. So let's do that one. And that one is going to be the x2 and the y2. And for this, we can actually duplicate everything that came before. So let's make some space over here and let's select these nodes, shift D them to over here, and let's connect the set position node like this and this set position node with the simulation like that. This set position should of course do it for the point where the index is equal to 2 and not to 1, of course. And then the only thing we need to change now is setting the theta 1 to theta 2 and the length 1 to length 2. But you will see if you do this, that's not really working, right? Because we also have to add x1 and y2 to this. So basically what we want is we want to have the position of this point converted to this point, kind of. So to get this, we can do an evaluate at index node. And the thing we want to evaluate is a vector because the thing is the position of each point. At the moment, what it's calculating, it's literally calculating the position of index 0. If you set this on 1, it will do it for the 1. If you set it on 2, it will do it for 2. But we want to have it that it's always calculating the index that came before. So to do this, we can add in an index node. And to say that it should do the index that came before, we can do a math node and set this on subtract. And we want from this index, we want to subtract 1 so that we're taking the previous index, of course. And then from this position, we want to get the x and y axis. So if you do a separate x, y, z, you can connect that like this. And now we have x and y axis. And this we can add to this. So let's make some space over here. So let's do a math node, which we keep on add, and let's press Shift D to duplicate it over here. And now let's add the x-axis to the x row and the y-axis to the y part over here. And then you will see, if you press play, we have a perfect working pendulum already, which is amazing. And with these formulas, it's really cool because not only is this point affected by this point, but this point is also affected by this point, which makes it hyper realistic. I think that's really cool. But there's way more that we can do to this. The first thing I want to show you now is how to actually control the parameters of this. To do this, you want to go to frame 1. So go to frame 1 so that the pendulum is in the initial position. Then you can go all the way back to our beginning parameters. And then you will see if you change, for example, the value of theta 2, you're changing the initial position of the second pendulum. Same for theta 1, you're changing the beginning position of the first pendulum. And then if you press play, you're getting a completely different pattern of pendulum, which I think is really cool. In the same way, you can just change the length of this one and the length of this one, and it will be affected by it, just like that. But I will set this back on 1 and on 1 for now. Let's actually take this pendulum and rotate it 90 degrees over the x-axis so that it will actually hang downwards. So let's do RX90 so that it will actually act like a real pendulum. And of course, we could have done like Y and Z, for example, so that it will automatically go down. But I think this is a bit easier. But now we just have one pendulum. What if we want to have like a lot of pendulums after each other, all in a different pattern? Well, for that, we're going back into the beginning of our geometry nodes. In here, we want to import a repeat zone. And this repeat zone, let's connect that with the simulation zone. And the iterations, the number of iterations is going to be the number of pendulums we want to have. So let's set this on 10, for example, for now. And let's also move these parts a bit over here and let's make some space. You see the geometry flows over here. Each iteration, I want to add this output. So let's do a join geometry node right over here. And let's connect this store named attribute with the join geometry. And each pendulum that we're adding to the join geometry should have some offset in the position, of course. So let's do a set position node. And as the offset, let's do a little bit of Z location like this. And then if you press play, you see that doesn't really work yet, right? Well, it doesn't really work yet because if we go back over here, we see the set position is only doing it for points that have an index of 1 or an index of 2. And those points are just this one and this one. If we add like a new curve, those will not have an index 0 to 1, but those will have like 3, 4, 5, 6, 7, 8, etc. So basically what I'm saying is we should not use the index anymore, but we should assign like a custom ID to each point so that each curve goes 0 to 1. And to do this, we're going all the way to the beginning of our geometry nodes, and we're going to do a set ID node. And this ID, we basically want that to be the index of each curve, so that each curve that is added in gets an ID of 0, 1, 2. But of course, that's not going to fix it yet, because in the two set position nodes over here, we have to change index to ID. So let's do an ID node instead of the index. Let's take this one, shift D it over here, and let's connect it like this. And then if we take a look, you see it kind of already works. The reason this is happening is because over here in those combine XYZ and the combine XYZ, the Z-axis is both 0. So those points are always going to be on a Z-axis of 0. It looks like the Y-axis, of course, but remember we rotated it 90 degrees, so it's actually the Z-axis. We can say that these points should have the same Z-axis as the point that come before this. So this point should have a Z-axis of this one, or this one, or this one, or this one. And we can do this by literally taking the position of the previous one, like what we did over here, and just connect the Z-axis like this, and then the Z-axis also over there. And then you will see it works perfectly fine. However, at the moment, the pendulums are exactly going into the same way. And that's because we haven't set an initial offset in angle yet. And to do this, we're going back into our repeat zone. And what we want to do is for each new pendulum, we want to get a different theta 1 and theta 2 value. So what we can do is just connect this value over here with theta 1 and this value over here with theta 2. And we want to cycle this throughout the repeat zone. So let's connect this one over here and this one over there. And each iteration, we want to add something to these. So let's do a math node, which we set on add. Let's put that over there. Let's do another math node, which we set on add 2. And then if you press play, you will see it's already working. And this is especially visible if you go to frame 1 again. So go to frame 1 and then you see this is how it starts right now. But if I set the add over here, you can make it start like this or start like that. I recommend to have these two values the exact same number. So if you add in a value node, you can connect this like that and just make this value node a small number like 0.001. And then you see there's a very small difference in initial angle. And then if you press play, you see that already works quite well. But now if you want to change the entire initial angle, you can go into the values of these and then change them like this. So the first one is theta 1 and the second one is theta 2. And then if you press play, you will see really that chaotic effect of a very small change in initial position will lead to a very different outcome. There are two more things that I want to show you in this tutorial, which are to replace each pendulum with an actual object and to make the pendulum draw a line in the air. However, before that, if you take a look at all these nodes, I can completely understand if you are thinking, I don't know what all of this is and how am I ever going to learn this? I wish there was some place where I can just learn all the nodes by myself in a very easy and chill way. Well, then I have good news for you, because a couple of months ago I released the Big Notebook. It's a book that explains in detail every single node within geometry nodes, and you will go from the very basics to very advanced techniques. The book is available on my Gumroad, so go to the link in the description to get your copy of the Big Notebook today. And with that being said, let's continue the tutorial. So let's first start with how do we actually make these pendulums look like pendulums, like actual objects, right? So in this tutorial, I'm going to make use of this object. I just quickly modeled a simple pendulum, and you see it consists of two objects. And what you want to make sure of is that the origin point of this object is quite over there, like at the end of the stick, so to say. And since our pendulum consists of multiple objects, we want to select both objects and put them into a separate collection. Let's press M and do new collection and name this pendulum or something like that. And now if we click on the actual pendulum and we go back into the geometry nodes, we want to instance that collection on each first pendulum. So let's do an instance on points node. Let's connect that over here. And as the instance, we want to drag in the pendulum collection like that. And then let's connect instance to instances. Let's also, for our visual purpose, let's add in a join geometry node so that we can join the curves also with it so that we can actually see what we're doing. It's literally putting it on every single point, but we don't want that. So to fix this, we want to make sure that this instance on points only instances this object on the points with an ID of 0. So let's take this ID node and this equal node, shift D it to over here, make it 0, and then we can say only do it for the points with an ID of 0, like this. However, then you might be thinking, but now it's not doing anything. That's because the rotation is not changed of these instances. We want that this rotation socket is dependent on the movement of the pendulum. So basically what we want is that this pendulum always points in the direction of this curve. And we can do this by taking this point and taking the position of this point, subtract it from each other, and that way we're getting the vector that always goes from this point to that point. So to do this, we kind of want to do the same thing as we did over here. We want to get from this point, we want to calculate the position of the next point. So not the previous, but the next one. So let's just take this index node, this subtract node, this position, and the evaluate at index node, shift D it to over here. And at the moment it's calculating the position of the previous index, but we want to have the next index, so we're going to set this on add. So now with a vector math node, which we set on subtract, we want from the original position, so the position of this one, we want to subtract the position of the next index, so this one. So now this is this vector, and to make the object point into that direction, we want to do an align Euler to vector node, and then the vector is going to be this vector. We want to set this on Y, and then the rotation is going to be the rotation, and then you see that works perfectly fine. And now if you press play, you see, yes, that works perfect. By the way, I forgot to tell you that your object that you're having in the pendulum collection, this one should be on the Y-axis laying like this. Otherwise, it's not really going to work. And also you want to make sure that the length of this pendulum is kind of 1 meter over here. so that is the same as the scaling over here. Talking about this scaling we can basically make that with a named attribute the length of pendulum 1. So if you put that over here, now if you change the length, it will also change the pendulum, which is really convenient. If you now want that the second pendulum is a different object than the first pendulum, then we can take this object, for example, Shift D it, right click so that it's on the same position, and then press M to put it in a new collection, and let's call this pendulum 2 or something like that. And now we're basically going to do the same thing. So let's take this instance on points node, Shift D it over there. Let's also duplicate these 3 nodes, connect the equal node with the selection, but set it on 1, so that it will only be on the point with index 1, and then connect the collection info 2. And for the points, we want to do the same thing. So connect the output of the simulation nodes right over here. And now connect this with the joint geometry. And then you see over here, it works like that. To fix this, we can do the same thing as before. We can literally connect this align Euler to vector with the rotation. And then that works already perfectly fine. And then for the scaling, we can take the named attribute, Shift D it to over there, and make this length 2. And connect that like that. So now we actually have a fully working pendulum. But now the last thing that I want to show you in this video is to make the outer point of each pendulum draw a line in the air. And to do this, we are for now going to focus only on the output of the simulation node so that we can see only the curves like this. Plus, for now, I also want to do this only for one iteration. Later, we're going to make this for multiple iterations. So let's go back over here. Basically, what I want to do first is make this endpoint leave a trail of points. And to do this, we can add in a simulation zone. And in this simulation zone, we're going to add a new point each frame. And we can do this with a join geometry nodes right over there. Connect the output of the simulation nodes like this. And then you will see this is the output. However, we don't want to duplicate the entire curve every single time, right? We only want to duplicate that endpoint. So we want to delete the other points. So let's do a delete geometry nodes. Set that over there. And for the selection, we want to use the same technique as with the ID and the equal. So we want to take these two, Shift D them over here. We want to say it should delete everything that has an ID less than 2. So let's set this on less than and connect that like this. And now if you press play, you see there is nothing. But the thing is, it will not show you those points because it's just loose points. To see these loose points, we can actually do a curve to points node. But now you see the method is on count. We set this on evaluated so that it will use the original points of the curve, so to say. But then if you press play, you see it already starts drawing a trail of curves, which is really cool. But now to convert these points into one long curve, we can actually do a points to curve again. Set that like this, and now we see it's already one long curve that it's drawing. If you want this curve to go a little bit smoother, the easiest way to do this is actually do a set spline type node and set this from poly to catmull-rom. And this method kind of smooths out the curve, so to say. And then to give this curve some thickness, we can do a curve to mesh node. And as the profile curve, we can do a curve circle, connect that with the profile curve. And of course, change the radius to a lower number so that you can have it like this, for example. I also recommend to set the resolution to like 7 or something like that, just to be a little bit more efficient with our computer power, of course. However, what if we want to do this for multiple pendulums at once? Because you will see if I now set the iterations on 4, for example, and I press play, you see this is happening. That's not really good. What is happening now is in the points to curves node, it literally tries to connect every single point as a curve. But we should tell this node that there should be 4 different curves, of course, not just one long one. And we can do this with this curve group ID. And this curve group ID is going to be dependent of the position of each curve. So to do this, we can do a position node. And then we want to make it dependent on the Z location, on the local Z location of each curve. So let's do a separate XYZ node, connect that like this, and then connect the Z with the curve group ID. Then you don't see anything happening yet. That's because the differences in Z-axis over here is too little. It cannot differentiate between the curves, so to say. And to make this difference bigger without making the actual distance bigger, we can do a math node set to multiply this by 100, for example. And then it works perfectly fine. And this way you're creating quite a satisfying effect. And now if we connect the curve to mesh with the joint geometry like that, you will see it looks like the curves are drawing a line in thin air. And of course, this line, you can give it a material. So you could go into material preview mode and then go into the shader editor by splitting your screen and go into the shader editor like that. And then change the name of the material to like trail or something like that. And then if you change the color, you will see that nothing is happening. And the reason for that is because we have to assign this material in geometry nodes with a set material node. And then if we connect it like that and we make this the trail material, then you see we can make that anything we like. And maybe, yeah, I like a more metallic look and also a less rough look, just like that. And with that, I think we have created a very cool effect. As you can see, mathematics can be quite cool if you apply it in a cool way, just like we did with the double pendulum. So I hope you liked this video. If you did, please give it a thumbs up, comment down below if you have any questions. And if you don't want to miss out on any future videos, I would consider subscribing to the channel. And with that being said, check out the Big Notebook and I see you in the next one.